Okay, so that takes us up to 90 degrees now. What's the coordinate at 90 degrees? What's the cos of 90? What's the x value right here on the y-axis? And the radius is what? So then what's the distance from here to here? 1. 0, 1, right? Okay, so there's the part of the first quadrant. Now let's go over to here. Now I have 120 degrees. All right, what's my reference angle here? 60 degrees. Here to here is 60, right? Therefore, I'm using the same values, the same ratios as this. What's the only difference? One's a negative. Which is negative? Cos or sorry, x or y? It's a negative x value, right? So there I have it. Yes. Okay? Cos is negative because x is negative. All right, so now I have 150 degrees. What are my ratios for 150 degrees? Negative 3 over 2 and 1/2. Because what's the reference angle? 30 degrees, the same as this guy. Does everybody see what's happening with the pattern now? Okay? Now this is going to be instrumental going ahead. This is something that they'll even put on the very first part of your exam. They give you a blank unit circle and you fill it in to start your exam in grade 12. Because if you have it in front of you, you can really solve a lot of questions quickly if you really have a good understanding of this. Okay, so now we're at 180 degrees, right here. What's the coordinate for 180 degrees? Negative 1, 0. Now we're catching on. 210 degrees. What's the reference angle? 30. So what do I have here then? Negative root 3 over 2. Negative 1/2. Right? So, 240 degrees. What's the reference angle here? 60. So what is the coordinates? Minus 1/2 and minus root 3 over 2. 270 degrees
is 0. No?
Okay. $300 degrees.
30.
What is the reference angle? 60. Yeah. So then what are the coordinates? Okay. You're on it. You're on it. You got one negative wrong, no?
It's correct.
Exactly.
3 over 2.
So it's 1/2 and negative root 3 over 2. Right? Because x is positive over here. So y is negative below the axis, right? Reference angle? 30. So what are we looking at there? Very good, Courtney. Okay, well, up. All the way around the circle. Okay? All of that was done using 30, 60, 90 triangles. All of that was based on the reference angle, whether it was 30 or 60. It's just straightforward. So now we aren't done yet because we had one other triangle that we had to work with, right? So using that other triangle now, 45 degrees. What are the coordinates for 45 degrees? What is the trig ratio for 45 degrees?
1 okay square 2.
1 over square root 2. Rationalized, what do we say? That's right. So what is it? Root 2 over 2? Root 2 over 2. Over here is 135. What are the ratios? What's the reference angle?
Minus square 2 over 2. Square 2 over 2.
That's right. Good. Minus root 2 over 2 and root 2 over 2. Because why? What is my reference angle for it? It's still what? It's still 45, right? So the ratios are still the same. The only thing that changes is the sign. Down here, 225 minus root 2 over 2 and minus root 2 over 2. And finally, 315. Again, the reference angle stays the same. Root 2 over 2 minus root 2 over 2. Okay? Now, you need to know it. You need to memorize it essentially, but realistically, is there any memorizing needed to be done? No. You need to know what a 30, 60, 90, what the trig ratios are, and it all stems from 1 over 2. The sine of 30 is 1 over 2. And then you need to know root 2 over 2 is your 45, 45. Okay? Now this is going to be significant to you as you go through because you're going to use this thing over and over again next year with one addition to it. Instead of writing in degrees, we write in radian measure, which is just another way of measuring degrees. All right? We measured the degrees by the angle here. Radian measure is the measure of this arc length. That's what it is. So when you go around a circle, you have 360 degrees. Well, the radius of this circle is what? 1. So what's the circumference of the circle? 2 pi times 1, which is 2 pi. So once around the circle is 2 pi radians. So that's what we look at. Okay? But this I want you to get familiar with now so that it's not brand new next year. All right? And it should have helped you, if we had done that yesterday, it would have helped you breeze through your assignment today, or from yesterday. Okay? All right. Now, that was just kind of a bonus round today. All right? Okay. All right. Take a look at page 81. The sine law. Brian, have you seen the sine law? I believe we did it in physics.
Yeah, I kind of wanted to get on concavity.
Okay, so the sine law says this. If I take the measure of this side A here, and I divide it by the sine of the angle across from it. When I divide it, it's going to give me the exact value as B over sine B, and the exact value of C over sine C. That's what the sine law does. Now, when we use the sine law, we're going to get an acute angle value every time. But what we've learned to this point is that if I find an angle, the sine value of an angle, there's going to be one other angle that has the same sine ratio. How do I find it? It's supplementary, exactly. It's 180 minus whatever that angle is. So remember when we did this in applied math, you had a triangle that could end up being 1, 2, or 3 sides, right? So let's take a look at an example, and we'll plug through it and make sense of it. Actually, let's do it like this. Okay, I'm just going to explain it from scratch again just to review it. All right, I've got an angle of 30 degrees here. I have a side length of 10. Okay? Now, I need the length of this missing side here to determine whether or not I have one triangle, two triangles, or no triangles. So the first thing that I do, I'll be given this length and I can figure it out. But for right now, I want to find out how is it that I can get 1 or 0 triangles. So how do I get one triangle? Well, I draw this down here, like that, and I find it. Now think about what happens here, and I explain this in applied. If this was a string hanging, right? So this side is just a string hanging, and it's hanging down here. The only place it can touch is directly below it to give myself one triangle, right? So let's find out what it is. Well, the sine 30 is equal to h over 10, right? What's the sine of 30 degrees? A half of 10 is 5. So if this side length that they give you is exactly 5, you'd have one triangle, right? What if the side length they gave you here was shorter than 5? Would it touch this side anywhere? No, because the string would be too short. So if it's swinging, it would be swinging up here somewhere, right? So the only way that I can get one triangle is if the string is exactly 5 units in length, right? If it's any shorter than that, it's 0. So if I label this that's B. So what I'm saying is this: if side A is less than H, I have 0 triangles. Right? So if they give you a measure for side A right here, and it's less than the value of H when you measure it, when you solve for H, you have 0 triangles. Right? If A is equal to H, how many triangles do I have? I have one triangle. Right? There's only one way I can do this. So this is the part that gets confusing to everybody. Well, how in the world can you get 2 triangles? All right, so I have a length of string. And when I hang that string out of here, it connects right there somewhere, right? Okay? I'm actually going to do this just a little less. I'll do it like this. All right, so let's say I've got a weight on the bottom of the swing, or on the string, and I let it swing. It's going to go like this. Gonna swing up, down, and back up. Right? If this string is somewhere greater than air, it's going to swing down here and it's going to come back up. So what have I done? I have created a second triangle. Right? You all remember this now? Okay. So if A is, how do I want to do this? If
Isn't it if B is less?
H is greater than A, no, we're going to do this the other way, and A is less than B. It's got to be H is less than A is less than B, right? So A has to be greater than H, but less than B. I'm going to end up with two triangles. Brian, are you following this? This is for you. Okay? So you see how this works, right? Okay. Anybody have any questions about this so far? You guys have touched on this, but now we're going to get into that. How do we get the second triangle? Okay? So, let's say that I give a length for A now. My A value is 8. All right? So I'm going to say that A is 8. So I'm going to create my first triangle. My first triangle is going to look like this. A, 30 degrees. B is 10. A over here is 8. So now I want to solve for this triangle. I want to find B. I want to find C. And I want to find side C. Okay? So the first thing I want to find is that guy right there. So let's do it. Sine B over 10 is equal to sine 30 over 8. Okay? So punch that into your calculator. 10 times sine 30 divided by 8, second function sine, because we're finding the angle. So 5 divided, second function sine of 5 divided by 8.
38.68.
Excellent, thank you. 38.68 degrees. So this is 36.68 degrees right here. Color. All right. What does that make angle C then? What's angle C?
111.
Point.
31.
Very much.
317.
317. Okay. Excellent. So you said 111? So 111.32 degrees. Right? That was easy to get because all I had to do was what? 180 minus 30 minus 36.68, and I got that. Okay? So the last thing I want to do is I want to find out what side C is. Okay, so sine 111.32 times 8 divided by sine 30. What do we get?
Isn't it 113.32?
Yeah.
113.32?
No, he wrote down 36 in the triangle and the rest is 38.
13.
Oh, this is 38.
Oh, it's
Yeah, that's okay.
Thank you. Update the office here. 38.68. Okay. So there we go. Okay, so what is side C then?
14.9.
14.91. So there's all triangle. There's the first triangle, right? Okay? So now, I'm going to do the second triangle. So the second triangle looks like this. All right, calculate angle B. Sine B is equal to, sine B over 10 is equal to sine 30 over 8, right? Okay, what do I get for B, angle B?
14.8.
14 for angle B.
I got it.
Hello. Yeah. In about 2 minutes, is that okay? Alright. Or you got it else. What do we get for B? What?
Just
38.
30.
38.68.
38.68.
Huh?
What I got.
There's an echo in here. What's the problem? That's what I got here.
So it's the same. No, it's not memory. No, it's
Ah, go ahead, Gabrielle. We have to subtract it from 180 because remember there's a second angle that gives you the same sine ratio. Right? So I didn't have to do this because I was going to end up with the same answer I had before. So how did I get angle B? Angle B is equal to 180 degrees minus the 38.68 degrees that I had before. All right?
Okay.
This angle and this angle will give you the same sine ratio. So what is 180 minus 38.68? 141.32 degrees. Perfect, thanks. So that means that this is 141.32 degrees. 141.32 degrees. Now, what is my angle C equal to? 8.68 degrees. All right, I take 180, subtract this, subtract that. That gives me 8.68 right there, right? Okay, so I have 8.68 degrees here. And now I have to use the law of sines to find that last side. So sine C, 8.68 degrees equals, and I still use 8 over sine 30.
Can you use B? I don't think you use A.
Yeah, you can, but what if you erred on B?
Then you can use A.
Well, no, I'm just saying, if you make an error here,
Then it's just gonna mess up all your.
then everything else gets messed up, right? So I don't use it until I check at the end.
Okay.
What do we get here?
2.41.
2.41? Excellent. Okay. And that, Brian, is how I get two triangles. Okay? You guys okay? Yeah? Good? All right, so we've done this in applied. We're doing it again today. The next thing that we have to do is the law of cosine, but I'll worry about that on Monday. Okay? Any questions from yesterday's work on the trig ratios? Anybody?
Can you go back though on slide to the circle or?